Federal, state, and local housing programs assume that households paying more than 30% of their gross income in housing costs, such as for rent and utilities, are cost-burdened. Housing assistance is usually targeted at very low-income, cost-burdened households. The American Community Survey offers two cross-tabulated tables that allow us to identify households that fall into the category of cost-burdened: gross rent as a percentage of income, and monthly owner costs as a percentage of income. Our goal here is to identify the number and percentage of households, whether renters or owners, that are cost-burdened. More specifically, this means the number and percentage of households in each block group that pay more than 30% of their gross annual income for housing costs. The first step is to acquire the latest ACS 5-year estimates for gross rent as a percentage of income and also monthly owner costs. So we'll start with American Fact Finder and go to the Download Center. We'll choose the American Community Survey as a program of interest. We're choosing the 2015 ACS 5-year estimates, which we'll add to our selection. We're working at the block group level. Working in Essex County here. Make our selection of the block groups. And we're looking for two tables in particular. We could browse through here, but we already know the names of them. The first one is a gross rent as a percentage of household income. We always want to look at the structure of that table to make sure it has the data that we want. We can see here that it gives us estimates of the numbers of households that fall within different percentage ranges. That is to say, the number of households who pay, for example, less than 10% of their income toward housing costs. This is what we want. We also want a table of data on homeowners. Here, the title of the table is a little more obscure. Mortgage status by selected monthly owner costs as a percentage of household income in the past 12 months. Again, looking at the table structure, we can see it's structured in a very similar way. Also with ranges of percentages, giving us the number of households who that fall in that percentage range. We have two categories, those with a mortgage and then those without. We're interested in the ones with a mortgage. So now we're going to download our two tables, and we're going to keep the descriptive data elements to make the data easier to edit. So I've downloaded the two tables from the ACS, which appeared as a zip file, which I renamed Housing 2015 to make it easier to read. And I unzipped that file into a folder, and I see within that folder that I have two sets of tables. One for the gross rent as a percentage of annual income, and also the mortgage status and household costs. We're going to start with the rent, and we'll focus on that for the remainder of the tutorial. There are two Excel or table files in here. Both are CSV files. If we double click on the first one that says metadata, we can see the columns or fields that are present in the data. And this is important because if there are a lot of columns, as there appear to be here, we need to be able to distinguish them. And we can see this looks a lot like the structure of the table that we saw when we looked online in the ACS Download Center. So when we work with data, though, we can't just double click on it and let Excel open it for us, because we're working with comma-separated values files or CSV files. Excel doesn't really know how to handle them, so we have to use the import function in order to bring the data in correctly. So I'm going to open up a new blank Excel workbook so that I can invoke that data wizard. So with the blank workbook open, I'm going to go to Data, From Text, and then I'm going to navigate to the folder where I saved my data. And so here now I'm interested in the file that has the ANN on the end. That indicates that we're working with the data we want. It's a delimited file, and it uses commas to delimit the columns. We want to specify the first two columns as text for sure, and that's important later on when we eventually join these tables to our shapefiles in ArcMap. So now that data has been added in, and so there are a few columns of interest to us. First of all, we want to have the total number of households, or rather housing units with renters. This is going to be our universe, and this is the one we're going to use when we calculate proportions. After that, we want the estimate. We also want the margin of error. We're going to need to retain that. But we're going to be able to get rid of a number of columns that aren't of interest. We don't really care about households who pay less than 30% of their income. So we're going to eliminate those columns in order to make the table a little more readable. So starting at the estimate of 30 or higher, we'll keep those. So we'll delete the rest of these. Okay, so now we just have the total number of housing units, and then we have those that are 30% or higher of their income, or who pay 30% or more of their income. So I'm going to add the columns of interest that we're going to calculate on the front end over here in front of the total. That way we don't have to move around the sheet so much. So I'm going to insert a new column where I'm going to calculate the total number of households that are paying 30% or more of their income toward rent. I'm going to give it a short title so that it doesn't cause a problem when we get into ArcMap. And so this calculation is very simple. We're just going to add up the estimates for households that fall within those categories of 30% or higher. So I'm going to start a function, and I'm going to add up the values in each of those estimates of interest. So I'm going to choose that first one and then just add it to each subsequent estimate of interest. And the last one there is 50% or more. So I hit enter, and then I get a total number of households who are paying 30% or more of their income toward gross rent. And so I can copy this formula down for the remainder of the cells. The shortcut here, I can just double click on that little green box in the lower right corner, and it automatically populates the rest of the cells with the same formula, so I don't have to drag anything around. Okay, so we've calculated we've aggregated rather the number of households that are paying 30% or more of their income toward rent. But because this is a derived estimate, we have to recalculate a new margin of error. And that formula is given by the following, in which case the margin of error for an aggregated count is essentially the square root of the sum of squared margins of error. We could break this into pieces, but we're going to do the whole thing in one formula to take up less space and to make the whole process quicker. So I'm going to add a new column in here where I'm going to house the the recalculated margin of error. And I'm going to also give it a short name here. Okay, so to construct this formula, which looks a little daunting on its own, we're going to start from the outside. So we know we're going to take the square root. So we'll start with the square root formula, and then after the opening parentheses, we can insert the sum of the squares. So what that means essentially is that we're going to take each of the margins of error for all of the aggregated counts. In case, for example, starting right here with the margin of error for the counts for those paying 30 to 34.9% of their income, and we're going to square that value by raising it to the power of 2, which uses the hat symbol, holding down the shift key, pressing on the 6 on your keyboard, and then putting a 2. So that's going to take the value in cell I3 and raise it to the second power. Then I'm going to add that to the next margin of error that I square and do the same thing. Close off the parentheses, hit enter, and we end up with our new calculated margin of error. So again, what we've done is we've squared each of the margins of error for all the aggregated counts, added them all up, and they took the square root of the entire thing. We don't need such a large number with so many decimal positions, so we can reduce that to just 1 decimal point. Okay, so now we have the estimated number of households that are paying more than 30%. of their income toward rent. We have a margin of error. We want to populate that down the column. So again, just double click on that box in the lower right corner. And you can see considerable variation from block group to block group here. Now we also want to get the percentage of households that are in that cost burden category. And so that's fairly simple. We're going to insert a new column here, and we're going to calculate the proportion. And so I'm going to indicate that it's a proportion by putting a Z, which kind of looks like a little percentage sign. And so this is very simply calculated as the estimated number of cost burden households divided by the total number of households, which is right there. And you can see 0.3 or 30%. We're going to populate the whole cell again by double clicking. You'll see some of these division or error values which indicate that you try to divide a number by 0. So in some cases we have essentially some values where there were no households there, so that's not going to work. We're going to come back to that in a second. The more important issue is that when we derive this proportion, the proportion is also a derived estimate, kind of like the aggregated count that we got here. So we need to compute a margin of error for the proportion as well. And so the formula for for calculating a margin of error for a derived proportion is this. So in this case, what's happening is that we're going to be taking the squared values for the margin of error for the numerator and subtracting the squared value of the proportion, which is multiplied by the squared value of the margin of error for the the denominator in the proportion. And then the whole thing is that we take the square root of that and we divide the whole thing by the denominator of the proportion. So we're going to again do this all in one cell to make it more efficient. So I'm going to insert a new column in here to house that value. And I'm going to give it a suitably cryptic name as well. Okay, so for this particular formula, although we solve the formula from the inside out, we're going to actually write it from the outside in. So we'll start with the square root again, opening up the parentheses. And now what we're going to do is we're going to take the margin of error for the numerator, which is the number on the top part of the equation that we use to calculate the proportion. So the numerator is the margin of error for the numerator is this one right here. And we're going to square that, so we're going to raise it to the power of 2. And then that is we're going to subtract from the squared proportion. So the proportion is this one right here. So we're going to take that value and we're going to raise it to the power of 2. And then we're going to multiply times the margin of error for the denominator squared. So the margin of error for the denominator is the margin of error for the total. So that's this one over here. And we're going to raise that to the power of 2 as well. And close off the parentheses. And then we're going to divide, and we need one more parentheses, there we go. Now we're balanced. And then we're going to divide the entire thing by the value of the denominator, which is in this case again the total, or rather the estimate of the total number of households. So this is going to be the value in H3. Okay, so looking closely at that formula to make sure it looks right. A lot of places to go wrong here. I believe it's right, so now we can hit enter, and we see we now have a margin of error for the proportion. So it's the same thing, same concept as the margin of error for the estimate. It's just that we're working with proportions now. So we can populate the rest of the column by just double clicking on that square in the lower right. And so again we filled it all. So last thing, we want to get rid of these error values because for two reasons. One, we can't use them, and two, if those are translated over as text when we go into ArcMap later on, Arc will have a problem interpreting the column because you can't have numbers and text in the same column. So what we're going to do to eliminate that issue is to use the if error function. And we're going to essentially leave our formula alone, but we're going to embed it inside, or nest it rather, inside of an if error function. So the if error function is just basically instructions that tell Excel to ignore situations where you get that error. And so what it involves is you leave the formula alone, but then you add instructions about what to do when it encounters an error. So I'm going to put two quotes side by side, no spaces, and close it off. And what that means is it's going to essentially leave that value, it's going to leave that space blank, so it'll treat it like there's no value there, which is more important for us. We don't want to put zeros in there because zeros would imply that there's a 0%, which we just don't know. We don't have any data for that. We want to do the same thing for the margin of error. We're going to nest it within the if error function. And then provide instructions about what to do. Two quotes, close it off. Again, populate it down. And they're gone. And so we see empty spaces. And that's, again, very important because we don't want zeros. Zeros imply a value. We don't actually have a value in that case. And so there we have now the estimates of the number of households that are cost burdened, as well as the margin of error for those counts, the proportion of households that are cost burdens, and the margin of error for those proportions.